Yes, dear students, today we take a class about the wave mechanical model of an atom. In my earlier class, I have told you about the de Broglie's concept of matter waves, derivation of de Broglie's equation, then the problems on de Broglie's equation, Heisenberg's uncertainty principle, and the problems on Heisenberg's uncertainty principle. Today we take the quantum mechanics. Knowing the limitations of Bohr's theory and introducing the concept of wave nature of electron and Heisenberg's uncertainty principle, a new approach is given to the structure of atom called quantum mechanics. In this quantum mechanics, it is a branch of science that deals with a mathematical description of the motion and interaction of subatomic particles, incorporating the concept of quantization of energy, wave particle duality of matter, and radiations and uncertainty principle. So, this quantum mechanics is an inclusive of all these contents. Let us study the wave mechanical model of an atom, which is the new theory to the structure of the atom. Although Bohr's concept of strictly defined orbits around the nucleus was abundant when de Broglie's concept of wave nature of the electron and Heisenberg's uncertainty principle came in light, Bohr's concept of existence of energy levels around the nucleus was retained in order to explain the atomic spectra. After the failure of Bohr's atomic model, the scientists were in search of a new model that could combine Bohr's stationary energy level concept, de Broglie's wave nature of electron, and Heisenberg's uncertainty principle. In 1926, Erwin Schrodinger, an Austrian physicist, developed a new theory to the structure of the atom called wave mechanical model of the atom. According to Schrodinger, the atom has a positively charged nucleus surrounded by a stationary electron wave, which extends round the nucleus in Bohr's circular orbit. He described electron as a three-dimensional wave in the electronic field of a positively charged nucleus. Schrodinger proposed that if the electron has a wave-like nature, it should obey the same equation of motion as all other types of wave obey. On the basis of this simple idea, he derived an equation which describes the wave motion of an electron wave along the three dimension, that is x, y, and z axis. This equation is called Schrodinger's wave equation, which is given below. The Schrodinger wave equation is d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m upon h square into e minus v psi is equal to 0, where psi is a mathematical function called wave function, represents the amplitude of the electron wave at various points surrounding the nucleus. M is the mass of the electron, H is the Planck's constant, E is the total energy of the electron, V is the potential energy of the electron. Schrodinger wave equation is a differential equation of the second order. Here I have shown the Schrodinger, the scientist picture, and he describes the probability of finding the electron surrounding the nucleus. So, by putting the idea of the de Broglie's concept and Heisenberg's uncertainty principle. He says in the one, instead of saying the orbits like K, L, M, N, he introduces the orbitals called the s orbital, p orbital, d orbital, f orbital. So he says in the first orbit we have one s orbital where that yellow shadow shows the probability of finding the electron. In the 2s orbital, so here its size is bigger, and between 1s and 2s there is a small white called the space called node. Node is a region where probability of finding the electron is less. When we take a 3s orbital, so it contains the two nodes, and the size of the 3s orbital is greater than the size of the 2s orbital, which in turn it is greater than 1s orbital. In the other side I have given a picture. 1s orbital is smaller in size. It is present in the first shell. 2s orbital is present in the second shell, and it also contains the two p orbitals which are dumbbell in shape, and next it contains the 3s orbital which is present in the third shell, explained by Schrodinger. Now here I have given about the de Broglie's concept, Heisenberg's uncertainty principle, and Schrodinger wave, and the comparison of the Bohr model with wave mechanical model. Here I have shown you, in case of the Bohr model, electron is treated as a particle, but whereas in the wave mechanical model of an atom, electron is treated as a wave. In case of the Bohr model, electron path is orbit, and the capacity of each orbit is to accommodate 2n square electrons. In case of the wave mechanical model, electron path is orbital, and each orbital it holds 2 electrons. According to Bohr's model, electron revolves around the nucleus in circular path. But according to the modern theory, not necessarily it must be the circular. Each energy level has specific energy in case of the Bohr's theory. The same holds good even in the Schrodinger's wave mechanical model of an atom. According to Bohr's, the exact position and speed of the electron can be calculated. So, according to the modern theory, probable location of the electron can be calculated. Now, let us take the Schrodinger wave equation, which I have told you in the previous slide. The same equation can be rewritten in this form, that is the del square psi plus 8 pi square m upon h square into e minus v to psi is equal to 0, where del square psi is a equation and where the del square is nothing but it is d square upon dx square plus d square upon dy square plus d square upon dz square, known as Laplacian operator. Now, let us study how this Schrodinger wave equation can be derived. This is an important point to be noted. It will be asked in the examination and also very important one. Schrodinger developed a mathematical wave equation to describe the wave motion of the electron in a hydrogen atom. Here the nucleus is surrounded by a vibrating electron wave called standing wave. The wave motion of the standing wave in one dimension is given as that psi is equal to a sine 2 pi x upon lambda. This is very important, the basic equation, that is psi is equal to a sine 2 pi x upon lambda. This is the equation number 1, where psi is an amplitude of the wave of wavelength lambda at a distance x from the origin A is a constant. Now, on double differentiating with respect to x, we get d psi upon dx is equal to a 2 pi upon lambda into cos 2 pi x upon lambda. Further differentiating this equation, we get d square psi upon dx square is equal to a into 2 pi upon lambda into 2 pi upon lambda minus sine 2 pi x upon lambda. On further the simplifying, I get minus 4 pi square upon lambda square into a sine 2 pi x upon lambda. So let us call this equation number 3. This is a very important equation, that is the Schrodinger wave equation in one direction, that is on x-axis. Substituting the equation 1 in 3, I get d square psi upon dx square is equal to minus 4 pi square lambda upon lambda square into psi. And this can be rewritten as d square psi upon dx square. Bringing this term into the left hand side, we get plus 4 pi square upon lambda square into psi is equal to 0. So we call this equation number 4. From de Broglie's equation, lambda is equal to h upon m into v. So by squaring this equation, I get lambda square is equal to h square upon m square into v square. Substituting the value of lambda square in the above equation, we get d square psi upon dx square plus 4 pi square m square v square upon h square into psi is equal to 0. Let us call this equation number 5. Considering the electron as a particle, the total energy of the system is nothing but it is the sum of kinetic energy, that is half mv square, and potential energy, that is v. The same thing can be written as E is equal to half mv square plus v, or v square is equal to 2 into bracket E minus v upon m. Let us call this equation number 6. Substituting the value of v square in equation 5, we get d square psi upon dx square plus 4 pi square m square into 2 into e minus v upon h square into m into psi is equal to 0. Therefore, the further simplification of this gives d square psi upon dx square plus 8 pi square m upon h square into e minus v into psi is equal to 0. This is the equation number 7. Equation 7 is the Schrodinger wave equation of a wave moving in one direction, that is x-axis. If an electron wave is moving in any of the three axes x, y and z, its wave function can be described by the wave equation d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m upon h square into e minus v into psi is equal to 0. This is the equation number 8. This equation is called Schrodinger wave equation. This equation can also be written as, instead of calling the d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square, this can be rewritten as del square psi. It is called Laplacian operator. Now the potential energy V is equal to minus Ze square upon R. This is the equation number 10. Ze is the charge of the nucleus, minus E is the charge on the electron, Z is the atomic number. Substituting the equation 10 in equation 8, we get d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m upon h square into bracket e plus ze square upon r into psi is equal to 0. This is the equation number 1. For hydrogen atom, Z is equal to 1. Therefore, Schrodinger wave equation for hydrogen atom is d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m upon h square into bracket e plus e square upon r is into psi is equal to 0. This is the equation number 12, which is called the Schrodinger wave equation for hydrogen atom. The simple Schrodinger wave equation is the equation number 8, and thus introducing the del square psi, the equation number 9, that is called Laplacian operator. The most probable radius for 1s electron in hydrogen atom from wave mechanics comes out to be the same as determined by Bohr, that is 0.0529 nanometer from his equation, that is R is equal to n square h square upon 4 pi square m e square z square. The meaning of this statement is, whatever the Bohr calculated the radius through his theoretical equation, that is the radius of the first orbit, which is also called Bohr's radius, which is nothing but it is 0.0529 nanometer. The same value also we get from the wave mechanical model of an atom by substituting the values in the above equation. Therefore, the wave mechanical model of an atom is a modern theory which also incorporates the Bohr's theory as well as it incorporates the de Broglie's and Heisenberg's uncertainty principle. It says the electron is having both particle character proposed by the Bohr and also it is having the wave character proposed by the other two scientists. Therefore, this equation is having both the terms, that is m and the psi. M is the mass of the electron, which is nothing but the particle character. Psi is the wave character of the electron. To tell this, I have given one more aspect here. That is how this atomic theory came into the existence starting from the Dalton. The Dalton's theory you have studied, and later on the Thomson proposes his atomic model, and further the Rutherford explained the structure of the atom by putting an idea of electron revolves just like planets revolves around the sun. Later on it was modified by the Bohr's theory. So here he says the energy levels. So electron revolves in a orbit having a particular energy. This theory also further extended by the Sommerfeld called Bohr-Sommerfeld theory by putting an idea of elliptical orbits. And finally, you have studied the structure of the atom based on Schrodinger's, the wave mechanical model of an atom. So this picture tells us about the whole history of the structure of the atom. Thank you.